Hello grade 9, in this video we will be talking about haloalkanes and isomers. Haloalkanes or alkyl halides are halogen derivatives of alkanes. They are compounds where a hydrogen atom in the alkane molecule is replaced by a halogen atom such as fluorine, chlorine, or bromine. Now in this example you can see that the hydrogen atom can be replaced by one of the halogen gases since they have 7 valence electrons and therefore they need one single covalent bond in order to achieve stability. Now we're going to learn how to name haloalkanes. Now in the naming process, each halogen is represented by a prefix. As you can see, fluorine as fluoro, chlorine as chloro, bromine as bromo, and so on. The rules to name haloalkanes are the same rules that we follow in order to name branch alkanes as we discussed in the previous video. First, we have to find the longest continuous carbon chain in the compound. We have to number the carbons of the main chain to give the branches the lowest numbers. Now, we have a remark here that in case the numbering from both sides gives the same number, we have to choose the side that will give the branch that's going to come first in the name of the compound the lower number. So the first possibility is the correct one because it gives the ethyl group the lower number, which is number 3, and we know that ethyl will come first in the name of the alkane. So to name the branch chain alkane, first we have to write the number of the branch, the name of the branch. We follow the same procedure again if we have a different branch, and we finish by the name of the by naming the main chain. In case we have the same branch, we have to use the prefixes di, tri, tetra, and so on. These same rules will be followed in order to name haloalkanes. In this first example, we have one carbon atom as the main chain and we have a chlorine atom as the branch. In order to name this compound, there are two ways. We can either start by naming the branch as chloro and the name of the main chain as methane, or we can follow the pattern alkyl halide by considering the methyl group, alkyl group, to be connected to the halogen, the halide, and therefore the name would be methyl chloride. In this second example, we have 2 carbon atoms as the main chain, and the branch is the chlorine again. Now there are two ways to name this alkane. We can start by the same rules that we explained. We named the main chain, which is ethane, because we have 2 carbon atoms. We proceeded by the name of the branch, which is chloro. We number the branch we number the main chain to give the branch the lower number, which is number 1. Or we can follow the pattern alkyl halide, alkyl representing the alkyl group ethyl because we have 2 carbon atoms, and the halide, which is the chloride. In this third example, we have a main chain consisting of 3 carbon atoms, and then we have a branch which is bromine. Now we can name this by using the rules that we know. First, the name of the main chain, which is propane. We proceeded by the name of the branch represented by the prefix bromo, and we number the carbon chain to give the branch the lowest number. From either side, we will have the number 2 pertaining to bromo. In the fourth example, we have 3 branches which are of the chlorine kind, and then we have only 1 carbon as the main chain, and therefore the name will end in methane. As we know, we have to use the prefix tri because we have 3 chlorine atoms. Now there's no need to number because we only have 1 carbon atom, but in this example, as you can see, we have 2 carbon atoms, and that's why we have to give each branch a number. The 3 are connected to the first carbon, and therefore each branch will receive the number 1. and the name would be 1,1,1-trichloroethane. Now in this example we have different branches. We have a main chain consisting of we have a main chain consisting of 3 carbon atoms. We're going to show you here. And we have 3 different branches. We have 2 from the fluorine kind, and then we have 1 chlorine. Now, in order, the name will end with propane, because we have 3 carbon atoms. Now, but we have to begin with the chlorine branch, because alphabetically the C comes before the F. So the chlorine is connected to the first carbon. That's why we have 1 chloro. We have 2 fluorines, and therefore we have 2 numbers, each for each branch. 3, 3. We have to use the prefix di because we have 2 branches of the same kind, fluoro. So we have 3,3-difluoro, and the name of the main chain, which is propane. The last example, we have 2 different branches. Also, we have a methyl. Branch, and we have a bromine branch. The name of the main chain is also propane because it consists of 3 carbon atoms, and the branches, because they're different, we have to see which one comes first in the alphabetical order, which is bromine, and therefore the number 1 will be for the bromine group and the number 2 for the methyl. So the name would be 1-bromo-2-methylpropane. Now, in case you had to draw the formula, we have to start with the main chain, and then we connect the branches. As you can see here, the name ends in heptane, and therefore we have to draw 7 carbon atoms. From the 4th carbon, we have to connect an ethyl group, which is 2 carbon atoms. And from the 2nd, we're going to draw 1 carbon atom as a branch to represent the methyl. And therefore, the formula would look like this, and we have to fill it with hydrogen atoms when we finish. In the second example, we have propane, which is a carbon chain consisting of 3 carbon atoms. From the first one, we can start from either side. We're going to connect a bromine atom, and from the second, we're going to connect a methyl group. And then we finish by filling with hydrogen atoms. According to the rules discussed previously, we have to remember that each carbon atom can form 4 single covalent bonds. Now, in this second part, we're going to talk about structural isomers. Now, we're going to look at these 2 structures, and we will have to count the number of carbon and hydrogen atoms. Now, if we count them, we can see that the molecular formula of both is C4H10. But when it comes to the name, the first one is a linear normal butane, while the second one is a branched alkane, a 2-methylbutane. Now, you have to notice that they have the same number of atoms, but the arrangement is different in each case. And this is what we refer by structural isomers. There are compounds which have the same molecular formula, the same number of atoms, but they have different structures or different arrangement, connectivity of atoms. Because these atoms have the same number, but they have different arrangements, they have different chemical and physical properties. The first one is used as a fuel for cigarettes, for lighters, and the second one is used as a refrigerant. Now, if you notice the melting point of butane compared to that of 2-methylpropane, you can see that the melting point and the boiling point, they decrease as we have more branches. as well as the density. So we have to notice that when the number of branches increases, the boiling point, the melting point, or the density will also decrease. Now we're going to see that in the next example. Now if we had to draw the possible isomers or possible ways for C5H12, and then we have to name them. The first way is by drawing it in a linear way, which is to connect 5 carbon atoms in a linear way. Then when we finish, we fill it up with hydrogens. As we know, the first one has to connect with 3 more, the second one with 2, the middle we have 2 hydrogens, and at the end we have 3. Now if we were to name this, the name would be pentane or normal pentane. Normal pentane has a boiling point of 36 degrees Celsius. Now the second possibility is to have a branch. In order to draw a branch, never choose the carbons that are at the extremities. Always try to take one from the middle, and we can connect it to the second carbon, and then we fill it with hydrogen. This is the 2-methylbutane. Now you can see the boiling point decreases. The third possibility is to drag this carbon to this side here, to the carbon, the second carbon, and therefore we have 2 branches, and then we fill it up with hydrogens. This would be a 2,2-dimethylpropane. And as you can see, as the branches increase, the boiling point decreases as well. Now, in case you have a problem filling with hydrogens, we have to follow the same rules that we followed up here. Now, we have to discuss the physical properties of alkanes. Now, this is a graph showing you the variation of the boiling point as the number of the carbon atoms increase. Now, for linear, and when I say linear, I mean the straight alkanes, as you can see, as the number of the carbon atoms increase, the boiling point increases. This same rule applies to the melting point or the density. As you can see here, we have 2 compounds. One which has 2 carbon atoms and the second one which has 3 carbon atoms. Now if we take a look at the boiling points, you can see that the boiling point increases from -89 to -42. And therefore the boiling point increases because the number of the carbon atoms increase as well.